Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at the second problem of our warm-up. This is the problem I did not get to in class and one that you will be getting tomorrow. This will give you a little bit of a heads up as I want to make sure that we continue to go through our process for trying to curve sketch. So we're going to be looking at 3 times x to the 2/3 power minus 2x. So let me write that down here so you can all see it. F of x equals 3x to the 2/3 power minus 2x. And the first thing that I want to do is I want to try to factor this. And I'm going to factor out the least power, and the least power is x to the 2/3. So I'm going to factor out x to the 2/3. It's going to leave me with 3x, and I end up with, it goes to 0, and minus 2/3 gives me minus 2x to the 1/3. Now it's with this that I can see that I have 1 0, and one of my zeros is x equals 0. If I then solve and I cube both sides, I end up with a second x, and that x is equal to 27/8. So I now have 2 zeros for the function. My y-intercept is also 0, so I can put that in as well. So let's start listing some of these things down. Okay, first of all, f of x has zeros at x equals 0 and x equals 27/8. F of x has a y-intercept at 0. Let's see, there are no vertical asymptotes, so f of x has no vertical asymptotes. F of x falls to the left, rises to the left, falls to the right. This is our left and right end rules. Let's see. There are no slant or horizontal asymptotes, so let's write that down. F of x has no slanting nor horizontal asymptotes. Okay, let's see, what else can I do? We'll need to find a relative minimum. So let's go ahead, and we once again have that origin, so we're going to have to find another point, but that'll be for our graphing purposes. So let's go ahead and find what is f prime of x. F prime of x, we're taking our original, power comes down, and we end up with 2x to the minus 1/3, and we have a minus 2. So I'm going to factor that out. Let's factor out the 2x to the minus 1/3. That's going to give me 1 minus x to the 1/3 power. And that gives me, what, 2, 1 minus x to the 1/3 power over x to the 1/3 power. So my critical values are 1 and 0. Just write those down. F of x has critical values of 0 I'll just have 1 minus x to the 1/3. Now keep in mind, if the 2 had a negative coefficient, I would have. And then we have 1 over x to the 1/3. Again, using test values. I now have f of x has a relative minimum at 0. F of x has a relative maximum at x equals 1. That just made my life a heck of a lot easier. Let's see, f of x is increasing on and that would be from 0 to 1. F of x is decreasing on, we're looking at negative infinity to 0 and 1 to positive infinity. Let's see, we're now going to need to take our second derivative. So let's see. I'm going to use this right up here, right there. So f double prime of x has to be negative 2/3 x to the minus 4/3 power, which is negative 2 over 3x to the 4/3. Notice 4/3 is never going to change sign. That value is 0 that we'll use. So I have negative 2 and 1/3. I'm looking at always concave down. So f of x make sure you can see that. So f of x has no points of inflection. F of x is always concave down. Now I notice that here I have an undefined situation, yet my original function was continuous. So at 0, f of x has to have a cusp. So let's write that down. F of x has a cusp. At x equals 0. Alrighty, I'm now ready to start graphing this. We have a cusp. It is also a relative minimum. It goes to a relative maximum. Relative maximum is right here at 1. Then cuts down. It has a 0. The zeros are at 0 and 27/8. Let's find out what this point is. 1, plug in the 1, and we have 1, 1. And then I have the rest of my curve still concave down and decreasing. Here is my curve. Oh, don't forget my origin, 0, 0. And there we go. So I have all of this information. That's my analysis. All the way down to that cusp. Here's my work. You kind of see the first and second derivative test. And then the curve that goes with it. And that is my second example for curve sketching. I hope this has helped. If it has, please remember to click like If not, please always remember to give me constructive criticism, as I always want to improve. Thank you very much, Hornets. Please be well and take care. Bye-bye now.